In this video, we're going to confirm that an inscribed angle is 1/2 of the intercepted arc. A pretty straightforward topic, but it's got a lot of uses to it. So let's just first confirm that the inscribed angle is 1/2 of the intercepted arc. On the screen, as you can see, the intercepted arc is where the two chords, in fact, if you were to extend these chords, they would keep going forever to make those angles. That would be the intercepted arc. The inscribed angle is always sitting on the circumference of the circle. So this inscribed angle can be anywhere on the circumference, but as long as it's sitting on the circumference, then we can call it an inscribed angle. Notice if it's off the circumference or if it's coming from the center, then it would not be an inscribed angle. Okay, I'll leave up this picture and then create a new circle, and we'll do a circle with a radius, I don't know, that looks about right. And now what we'll do is we have a circle, a sizing circle. We'll put that anywhere we want, and then we'll create a second point on the circle, say here, and a third point to create our angle. Our angle will come from point F. So it doesn't really matter where we put it because we can drag it later, but let's put it here. And now we'll create the segments to make the angle. Again, it's going to start at F, going to go to G, F to H, and that gives us our inscribed angle. And again, that allows us to move H back and forth, G back and forth. We can even move F if we like. F will control the size of the circle as well. Okay, now what we're going to do is we're going to try to make the arc that's on the outside here. So to do that, we'll go use the arc tool, which is below the circle tool. Here we go. And it is the circular arc with center and 2 points. So we'll click on that option. We'll pick the center point, and then H and G. Actually, I went the wrong way. We want to go from E to G and then H. That'll create the minor arc. If you went the other way, it would create the major arc. Now it's hard to see because they're all the same color here, so I'll go ahead and change this color to something else. And then just change the thickness a little bit so it sticks out a little more from the circle, the circumference. In case you're curious, by the way, how we made the segments in an earlier lesson, if you go to the color scheme of the arc, if you drag that color scheme, that's how I made the segments previously, if you're curious how that came about. Alright, so now we have the minor arc, we have the inscribed angle, and our goal here is to ensure that the minor arc is 1/2 of that, the inscribed angle is 1/2 of that minor arc. So let's measure both. So let's measure the inscribed angle first. We'll use the angle tool. Again, go clockwise. And so this angle, again, I'm going to use the rounding option just so we don't get cluttered with the decimals here. And it's a little more than 60, but it's approximately 60 degrees, that angle right now. So it's rounded a little bit, but just the logic behind this, the measure of that minor arc, the opening of that arc, should be double the 60. It should be close to 120. It would be more than 120 because I used rounding here. So let's actually measure that arc. When we created the arc, it's already, I believe GeoGebra already highlights it for us as 7, but we don't want the measurement, the length. That's the arc length. That's how long it is. We're looking for the opening itself, the measure. So to figure out the measure, we are going to connect it to the central angle because the 7 represents the arc length. We're looking for the arc measure. So we need to do a little bit more work before we actually figure out the arc measure, and that is to create the central angle. So using the segment tool, go ahead and make that central angle. So now we have a central angle. So we have the inscribed angle 60 degrees. We now have the central angle. The opening of the arc always matches the central angle. So let's go ahead and measure that central angle now, and that'll equal the measure of the arc. So in a clockwise fashion. And with the rounding, it is 120. And look at that. So the arc itself, the opening of the arc matches the central angle, and the inscribed angle is 1/2 of the central angle, which matches the opening of the arc. So that's how they're all connected. And if we go ahead and drag around the points, we drag around G, you'll see the only time it'll be slightly different is when GeoGebra rounds. So maybe I shouldn't use that much rounding because then it looks like it's off a little bit. Maybe I'll use 1 decimal place, so then the rounding is clear. So as you move G, you can make that inscribed angle bigger, and notice the connection between the inscribed angle and the arc measure. Arc measures double the inscribed angle, and that'll work. Even if you crisscross, it'll work. So that's the quick lesson there, and you can go ahead and move it around here. And notice, I want you to also notice that you make another quadrilateral. So this is an interesting application here, because if you know the inscribed angle, you automatically know the central angle. The central angle is always going to be double the inscribed angle, and that's going to be the arc measure. So if you know any of those pieces, you can get the other pieces, and you notice that you're creating another quadrilateral on the inside. So in an upcoming lesson, you're going to work with all of these chords. These are all chords right here. This is a chord, this is a chord, this is a radius, and then another radius. You can figure out the missing sides of that quadrilateral or the missing angles coming up. So this lesson is purely just to show you that the inscribed angle is indeed 1/2 of the central angle, which matches the arc measure.